Hello, dear students. Today in this lecture, let us study about some of the important features of oxoacids of phosphorus. The first feature that we need to study is the composition of oxoacids are interrelated in terms of loss or gain of water molecule or oxygen atom. For example, if you look at this S3PO2 plus O that gives us S3PO3, S3PO3 plus O that gives us S3PO4, H4P2O5 plus O that gives H4P2O6, H4P2O6 plus O that gives H4P2O7. Now let us study some more example that if you have H3PO3 plus H3PO3 by the loss of water molecule, we will get H4P2O5. Then if you have H3PO4 plus H3PO4 and by the loss of water molecule, we may get H4P2O7. So this is how, my dear students, we get the various acids. Suppose if you have H3PO3, sorry, H3PO4. So if you take 3 molecules of H3PO4 and if 3 water molecules are being removed, then we may get HPO3 thrice, which is known as the cyclometa phosphoric acid, or you can say it cyclometa triphosphoric acid. And if you have n number of S3PO4, my dear students, then by the removal of n water molecules, we can get HPO3N, which is polymeta. So let me write the names for this at least. Cyclotrimetaphosphoric acid. This is cyclotrimetaphosphoric acid. And this is what it is, polymetaphosphoric acid. Polymetaphosphoric acid. So this is how, my dear student, we truly understand about the how these oxoacids are interrelated with each other. Now, my dear students, we are going to study about the second feature of the phosphoric acid. So, please remember these points which we discuss here. All in all the phosphoric acid, in all the phosphoric acid, all the oxoacids of phosphorus, in all the oxoacids of phosphorus, in all the oxoacids of phosphorus, my dear students, phosphorus undergo sp3 hybridization. Thus, we can say phosphorus is surrounded tetrahedrally by other atoms in oxoacids of phosphorus. So this is how, my dear student, we understand that in all the oxoacids of phosphorus, phosphorus is basically um, having the sp3 hybridization, and thus in all the oxoacids of phosphorus, phosphorus is surrounded by the other atoms in the form of in the tetrahedral manner, or phosphorus is surrounded tetrahedrally by the other atoms in the oxoacids of phosphorus. Then, my dear students, the next point that we need to study about is all the oxoacids of phosphorus has at least one P double bond O bond and POH bond. So this is the necessary condition for this is necessary condition for a compound of phosphorus to be called oxoacid. So please remember, my dear students, for any compound of phosphorus, if it should be called oxoacid of phosphorus, it must have at least one P double bond O and at least one POH bond. So this is how, my dear students, we understand. Now we have the next point to study about, that the oxoacids with oxoacids with oxidation state of phosphorus less than 5, that is +4 or +3, have have PP or PP or pH bond present in their structure. Remember, my dear student, that both PP and pH bond cannot exist simultaneously in the structure of any oxoacid of phosphorus. Remember, my dear students, that apart from PP or PH bond, POP bond is also found. But this is how, my dear students, we understand the presence of the bonds. Now, if you have any doubt, you can ask me. Let us understand this with the various examples. If we look into the structure of our H3PO2, you can see that same way if you look at H3PO3, or if you look at the structure of H4P2O5, this is your H3PO2, this is H3PO3, this is H4P2O5. Here you can see that the oxidation state of H3PO2 phosphorus exists as a +1 oxidation state. In H3PO3, phosphorus has got +3 oxidation state, and in H3P2O5 also phosphorus has got +3 oxidation state. Here you can see that we may have either this pH bond. Here also we have pH bond, or we have POP bond as well as pH bond existing simultaneously. So here you can see that, my dear student, that we have this kind of bonds possible. Even there is one more oxoacid which is known as H4P2O6. If we think of H4P2O6, H4P2O6, we will find the P bond in it, P, then double bond O. Then we have the 4OH, H4P2O6. So here you can see that this PP kind of bond is possible in this particular case. And here the oxidation state of our phosphorus is found to be, the oxidation state of phosphorus is +4. So when the oxidation state is less than +5, please remember, my dear students, that when the oxidation state, when the oxidation state is less than +5, we may get pH, POP, or PP kind of bonds in oxoacids of phosphorus. These are the few important things that we can learn about. Let's move to the next point or next feature of our uh, oxoacids of phosphorus. So the next feature is, my dear students, that pH bond if present in the oxoacids of phosphorus, pH bond if present in the oxoacids of phosphorus, my dear students. First thing about it, a very important thing about pH bond is it is not ionizable. So pH bond is not ionizable. Then we have the next characteristic, my dear students. pH bond is responsible for reducing character of oxoacids, and therefore, my dear students, we can say that, and therefore, oxoacids, example, H3PO2, H3PO3, and H4P2O5 are reducing in nature. H3PO2 reduces AgNO3 to metallic Ag. So let us write the chemical equation for this. We can have 4AgNO3 and 2H2O, and then we have H3PO2. Out of this 2H2O, we have 2 oxygen which is added to H3PO2, so it gives us H3PO4. And then, my dear students, you can easily see that this 2H2 which gives 4H, this 4H combines with HNO3 to NO3 minus to give 4HNO3, and we get 4Ag, which is a metallic. So you can see that Ag is reduced from +1 to 0, and our phosphorus is oxidized to +1 to +5. So this is how, my dear students, we can see the reducing nature of H3PO2. So please remember that this pH bond is responsible for the reducing character of our oxoacids of phosphorus. Now, my dear students, we are going to study one more very important and very nice characteristics about the oxoacids of phosphorus, that the POH bond present in oxoacid is ionizable. It ionizes and give H plus ion in aqueous solution. Thus, number of POH bond represents, or we can say determine, the basicity of an oxoacid. So let us understand this, my dear students, the number of POH bond determines actually the basicity of a particular oxoacid. So let us look at the various oxoacids and their basicity and their number of OH bond. Let us study it in so that we can remember it, and whenever we are asked question, we can easily answer such questions. So let's pay attention and understand it. Let's move forward, my dear students, and study first. So the first thing that we have is the oxoacid that we have. So first let's look at the oxoacid, my dear students. Oxoacid, then number of POH bond, and basicity. So let's start with the first one, which is H3PO2. It has got one POH bond and it is monobasic. Same way, my dear students, we are going to study the various oxoacids like H3PO3, then H4P2O5, then my dear students H4P2O6, then we have H3PO4, then H4P2O7, then my dear students we have HPO3 thrice, and we may have HPO3N. So now, my dear students, if we write the number of POH bond present into it, here it will be 2, H4P2O5. So here again it will be 2 POH bond present, my dear students. In case of H4P2O6, we will have 4 POH bond present. In case of H3PO4, we have 3 POH bond present. In case of H4P2O7, we will have 4 POH bond present. In case of HPO3 thrice, we have 3 POH bond present. And in case of HPO3N, my dear students, we have N POH bonds are present. Thus, we can say our H3PO3 is dibasic, or basicity is equal to 2. Then H4P2O5 is also dibasic. Then, my dear students, H4P2O5 is tetrabasic. Then this is again tribasic, H3PO4. I'm sorry. Then H4P2O7 is again tetrabasic. Then HPO3 thrice is tribasic. And HPO3N is polybasic, my dear students. So if we want to write the basicity in terms of numbers, we can even write it this way, that basicity is equal to we can write basicity is equal to 1, basicity equal to 1. Same way, my dear students, we can write the same thing. Just 1 minute, hold on, please. So, my dear students, for diabasic, we can, no, it's not possible. We should write it little. The basicity, in monobasic, the basicity is equal to 1. For diabasic, we can write basicity is equal to 2. For both the diabasic, we can write, and then for tet, so we can write it here, basicity, or my dear students, we can even write it this way, that the number of POH bond is also equal to basicity. So equal to basicity, and this is how we can write it for all. So see, we can write the same for all of them. So the number of POH bond represents the basicity in a very nice manner, my dear students. You can see that. So this is how we study and understand, my dear students. So this is what we should know about the basicity of the oxoacids of phosphorus, my dear students. Then we have the next feature to study about the oxoacids of phosphorus. And my dear students, this next feature is about the disproportionation of the acids. So oxoacids of phosphorus oxoacids of phosphorus in +3 oxidation state, in +3 oxidation state, disproportionate to give higher and lower oxidation state compounds simultaneously. So let us understand this. This is what it happens, my dear students, with an oxoacid, that is H3PO3. You can see that the oxidation state of phosphorus in H3PO3 is +3. So this H3PO3 simply disproportionate. So when we heat it, it disproportionate and gives us PH3 and 3H3PO4. This is how it goes, and we get the disproportionation reaction. You can see that here the phosphorus is in the -3 oxidation state. The phosphorus in this phosphine is present as a -3 oxidation state, and here phosphorus is available as a +5 oxidation state. So this is how, my dear students, the oxoacids in +3 oxidation state disproportionate. Now, dear students, let's look into some of the in-text question for from our textbook. That how do you account for the reducing behavior of H3PO2? This is the question, that how do you account for the reducing behavior of H3PO2 on the basis of its success, on the basis of its structure. Please remember, my dear students, to explain this, let us first draw the structure of H3PO2. So P double bond O, then we have OH, and we have 2H. We are well aware, my dear student, that this 2H are called the reducing H. This 2H we call it as a reducing H, this one and this one. So these two reducing H are responsible for the basic reducing property of H3PO2. In H3PO2, in H3PO2, two hydrogen atoms are bonded directly to P. Two hydrogen atoms are bonded directly to P or phosphorus. Phosphorus atom which imparts reducing character to the acids. Phosphorus atom that imparts reducing character to the acid. So this is how, my dear student, we answer this very simple question. Then we have the next question. The next questions ask us that what is the basicity of H3PO4? What is the basicity of H3PO4? To answer this question, my dear students, it's very simple. Let's draw the structure of H3PO4. In H3PO4, we have four or three POH bond. So we can answer this question. In H3PO4, we have three POH bond. And therefore, basicity of H3PO4 is 3, or it is called tribasic acid. So this is how we can answer this question, my dear students. Now if we have the next question, what happens when what happens what happens when H3PO3 is heated. My dear students, it's very simple to answer this question, that when H3PO3 is heated, it disproportionate to give PH3 and H3PO4. So let us write the chemical reaction for this. 4 H3PO3 on heating gives PH3 plus 3 H3PO4. So here, my dear students, we complete the discussion about the various features of the various oxoacids of phosphorus. I hope you have enjoyed your studies, and if you have any doubts, you can ask me, my dear students. I wish you happy learning.